Okay, so up next we have the brake. So how the brake subsystem works, mechanically, is we have this linear actuator. This was also added by Phase 1, and the actuator is able to move in and out. And the way it's set up is with the pulley here and this wire, it's connected around the other side here to the brake pedal. So when we tell the actuator to pull in, it actually pulls on the brake pedal. So if we get the shot from the actual actuator, some things to be aware of is that the mount for the actuator, location here, if you turn the steering too far to the right, the tire will actually come into contact with this mount here, which is a problem. As well, right now we're software controlling the actuator and limiting how far it's able to travel. And that's to make sure that we keep some level of tension on the lines that we're able to stop. And that's also because if the actuator is allowed to extend all the way, it'll actually crash into this pulley mount here. So certainly some advice that we would give you as a future team would be to investigate using a new actuator. It wouldn't have to be nearly as large. Preferably it would actually be a little bit faster than the actuator that we have currently, and develop a new mount for it, so that way it both doesn't crash into the pulley here, and then also allows for the full range of motion for the steering rack here. So how that's actually controlled is via 3 wires, and if we go around to the back, the actuator is getting driven by the Sabertooth 2X12 RC, which is here, and that's being driven from a servo signal, or servo type signal from Due 1. So the way that works is that on that yellow wire there, we're giving between a 1 and 2 millisecond pulse at 50 hertz, 20 millisecond. And what that's doing is at 1.5 millisecond, it's doing nothing. At 1 millisecond, it is retracting the actuator, and at 2 millisecond, it is extending the actuator. And how that's working on the Sabertooth and how that's configured is that it changes the polarity on 4 wires, but really in reality it's actually 3 on the actual actuator. And by changing the polarity, you're able to either retract or extend the actuator. You can see the theory of operation manual for how that circuit actually works and what combination of what wires, what polarity causes the actuator to do what it needs to do as far as extending and retracting. And there is a potentiometer that is built into the actuator, and what we do is we read that potentiometer to get the value for the actuator. And then the subsystem works by taking and comparing the desired value that you want for the brake to the potentiometer value that it is at currently, and decides to either extend or retract the actuator. And something to be aware of is that we can't control the speed of the actuator. It's either extending or retracting at a constant pace. So to get it to not oscillate, you'll see in the software that we actually have a delay system. So as it gets closer to the desired value, that it delays extend or retract cycles to dampen that oscillation. Basically, yeah, like a PWM type signal.